So picking up where we left off then yesterday with part C, the solid S, which we did yesterday, right? We took the region from 1 to 4 of 1 over root x and revolved it around the x-axis. That gave us the solid S, volume in D. For part C, we want to find the average value of the areas of the cross sections that are perpendicular to the x-axis. So the cross sections, each of their areas, remember, was pi, and then times our function. That's our radius squared. And so if we want to find the average value of that from 1 to 4, all we have to do is do 1 over 4 minus 1 times the integral from 1 to 4 of this, which happens to be pi over x dx. Everybody good with that setup? Find that average value. Yeah. Okay. And so then we end up with pi over 3 natural log absolute value of x from 1 to 4, which gives us pi ln 4 over 3 minus pi ln 1 over 3. ln 1 is 0, so just pi ln 4 over 3. And that was worth just 1 point for the answer there. Good or no?
Good.
Wonderful. All right. And then the last part here, which was part D, told us that the average value of a function on an unbounded interval from a to infinity is the limit as b approaches infinity of the integral from a to b of f of x dx over b minus a. So we want to show that the improper integral from 4 to infinity of g of x is divergent, but that the average value of g on that interval is a finite value. So first we need to show that g of x is divergent from 4 to infinity, which I don't think we did. We didn't do that for anything else. No. Okay, so we're going to do since we're going to do the integral from 4 to infinity of g of x. That was g of x, right? 1 over root x? Yeah. So first off, we're going to rewrite that as a limit as, well, I don't know, you call it b or a or whatever you want to call it. The limit as b approaches infinity of the integral from 4 to b of x to the negative 1/2 dx. We integrate. The integral of x to the negative 1/2 should be 2 root x from 4 to b. And we end up with the limit as b approaches infinity of 2 root b minus 2 root 4, which we can say diverges because as b goes towards infinity, 2 root b is infinite. And infinity minus 4 is still infinity. Everybody good with the first half of part D?
Good.
Okay. Second half of part D wants us to show that the average value of g on that interval is finite. So how are we going to do that? We're going to have to set it up like this, right? We're going to do our limit as b approaches infinity of the, it's just the integral of this, right? Which is 2 root x over, and then we had a, our b value was b minus our a value, which was 4, evaluated from 4 to b. Good or no?
Good.
Okay. So then all we need to do, well, sorry, this should be, I've written this poorly. That's the only part that we're evaluating from b to 4 is just that top part. And so then this becomes a limit as b approaches infinity of 2 root b minus that 4 over b minus 4. And as b goes towards infinity, the minus 4s in both the numerator and the denominator become insignificant. And then we just have 2 root b over b, which should go towards 0. So the average value of that function on that interval is 0, but there is no finite value for that interval. And that was worth 4 points. So you would have gotten 1 point for having 2 root b minus 4, 1 point for stating that it diverged, 1 point for getting to here, and 1 point for saying that that was 0. Everybody good with that? Any questions on that?
I have a question.
Okay.
Could you have done a thing where, since the numerator approaches infinity and the denominator approaches infinity, you just use L'Hopital's rule?
Yep.
Okay.
Good. And then you have 1 over root b over 1. So it's really just 1 over root b.
Yeah.
Yep. That's fine.
Yeah. Because I just thought like the second part of part D is supposed to like relate to the first part of part D. And since you found that like the first part of part D approaches infinity, like I just thought like that assumed that you should use L'Hopital's rule for like the second part.
I mean, however you want to evaluate that limit is fine. The hope is you can just look at that limit and be like, the top's increasing more quickly. So the top's increasing less quickly than the bottom, even though they're both going to infinity, so it's 0. But if you do L'Hopital's rule, it does the same thing. So either way is fine.
Okay, thank you.
Yep. Anybody else? Any other questions on that?